Here we are with another lesson, Module 4. Lesson 4, problem set. Your objective is that we're going to be able to use, or you're going to be able to use tape diagrams to model fractions as division. So we're going to be using another strategy called tape diagrams to be able to show how fractions are the same thing as division. So let's get started. All right, let's go ahead and read the directions to see what we need to do to be able to solve some of these problems. They want us to draw a tape diagram to solve. They want us to express our answer as a fraction. That means show our answer as a fraction and show multiplication sentence to check your answer. So three things that we have to do because we have one verb. We have another verb, express, and then show. So three things that we have to do. The first one's done for us. We'll use that as a model. All right, let's look at 1b. We have 2 divided by 3. So let's pretend our tape diagram represents the dividend, represents the number being divided up. The number being divided up is going to be 2. So think of like 2 cookies. And our divisor is how many groups we're putting the 2 in evenly. So we're going to be dividing it into 3 groups. So you can see we've got 1 group, 2 groups, 3 groups. The number 2 needs to be evenly divided into the each group. So if we follow the steps, we're going to say, okay, 3 units, that means 3 boxes, total altogether, these 3 boxes altogether equal 2. So we're going to write 2. Now we want to figure out what one box is. We want to figure out what this box is, which is going to be the same as this box and this box because we're dividing, and that means we're going to be doing it equally. And so we're going to say, okay, if we need to figure out what 1 unit is, that means we're taking the number on top of the tape diagram, which is 2, and dividing it into 3 boxes, which we know from our last 2 lessons, 2 divided by 3 means, remember the dividend is the number that goes up on top as the fraction numerator, and the divisor is the number going to be our denominator. So that means each box is going to be 2/3. So if we had 2 cookies and we had to divide it between 3 people, each person would get 2/3. And so now we got to go ahead and show division. Remember, we're doing 2 divided by 3. So 2 is inside the division house, 3 is on the outside. Now, if we counted by 3s, can we get to 2 without going over? So we have 3, 6. Oops, nope. Even the first one, 3 is too big. So actually 3 cannot go into 2. So that's going to be 0. 0 times 3 is 0, and that means what's going to be left over when we subtract? We have 2, and that's actually going to be our answer. Our answer is going to be 2/3. Our remainder becomes our numerator, and the divisor, the number we're dividing into groups, is going to be our denominator. Now we're going to check this by saying, okay, if we take our divisor, which is 3, and we multiply it by our answer, which is technically 2/3, that means, I'll do it in blue, we're going to be doing 2/3 plus 2/3 plus 2/3. If I add those all up together, that would give me 6/3. And remember, 6/3, 6/3, also means as a division sentence 6 divided by 3, which then would give us 2, which matches the number up on top of the tape diagram. So we got the right answer. All right, let's move on to the next one, 1C. All right, 1C, go a little bit faster since we'll see some patterns. Remember, we're doing a tape diagram. We're not going to be drawing out 7 little rectangular pictures of cookies or crackers or whatever. We're going to use a tape diagram. Remember, this is going to be our dividend, the number that we're dividing up, which is 7. And how many groups are we putting the 7 into, dividing it into? We're doing it into 5 groups. So we need to do 4 lines. And so now to figure out what each box is, because each box is going to be the same value, these are all going to be equal to each other, and they're not going to be different. We just need to figure out what one box is. All right, so how many units or how many boxes do we have? We have 5 units. And if you add those 5 boxes up, they would actually equal 7. Well, now we want to figure out what 1 unit is, what 1 box. That means we're going to take this number 7 and it's going to be divided into 5 boxes. So our division sentence is going to be 7 divided by 5. Remember, 7 divided by 5 also means a fraction, and that is 7 over 5. And that actually is going to be greater than 1 whole, because you can actually pull out 5 fives, 5 fifths, that's 1 whole. What's left over, you're going to have 2 fifths. So each box right here is going to be 1 and 2 fifths. They're all going to be the same because we divided up equally. If you want to think of cookies, 7 cookies of between 5 people, each person would get 1 whole cookie and then 2 fifths of a cookie. Let's go ahead and do some division. We're doing 7 divided by 5. 7 goes on the inside, 5 on the outside. 5 can go into 7 only 1 time. Because if you count by 5s without going over, you can count just once. 5. 1 times 5 is 5. We're going to put it underneath our 7, and we're going to subtract what's going to be left over. 2. 2 is going to be left over, which becomes our numerator, and our denominator is 5. And so now we got to check this, and I might need to write a little bit smaller. I'll do it in red. So try to squeeze this in the best as possible. Actually, let's scoot over a little bit. Oh, I can scoot over a little bit. Yeah, that would work. Let's go ahead and we're going to take our divisor, which is 5, and we're going to multiply it by 1 and 2 fifths. And our goal is, after we get the final answer, it should match the 7, and that will tell us our answer is correct. So let's think. Okay, 1 and 2 fifths times 5 is saying 1 and 2 fifths plus 1 and 2 fifths plus 1 and 2 fifths plus 1 and 2 fifths. One more time, plus 1 and 2 fifths. So if I add the whole numbers up together, I've got 5 right there. And then if I add up my 2 fifths, I've got 2 fifths plus another 2 fifths. That's 4 fifths. Plus another 2 fifths. That would be 6 fifths. Plus another 2 fifths would be 8 fifths. And another 2 fifths would be 10 fifths. So 10 over 5. But this is bigger than a whole. And remember, 10 over 5 also means, as a division sentence, 10 divided by 5. We should know that 10 divided by 5 is actually 2. So this right here, 10 over 5, is actually 2 wholes. So now if you think about it, we have 5 wholes plus 2 wholes, and that would be 7 wholes. And that matches our dividend, the number on the inside. So 1 and 2 fifths is the right answer. All right, for 2, what they want us to do is to fill in the chart, which is the first one's done for us. So let me look at the first one. 1a, here's the division expression with no answer, just the problem. Here's the fraction. They want us to figure out, okay, between which 2 whole numbers is your answer going to be between. So this fraction is in between 4 wholes and 5 wholes. And here is the standard algorithm. So let's go ahead and do B, 6 divided by 7. Well, as a fraction, we should know that's going to be 6 over 7. And 6 over 7 is not bigger than 1, so they tell us it's between 0 and 1 whole. This fraction is very close to 1 whole. Now let's go ahead and do our division over here. We've got 6 divided by 7. If you count by 7s, can you get up to 6 without going over? No, you can't. So we're going to put a 0. 0 times 7 is going to be 0. We're going to subtract. 6 minus 0 is 6. That's our remainder, but turn that into a fraction, and that's going to be your numerator, and the divisor will be your denominator. So that matches what we have, 6/7 over here. All right, let's move down to C. Now C, they don't give us our expression, but they do give us our fraction, 55 over 10. Remember, this is another way of writing a division sentence. 55 is our dividend, and 10, which is the denominator, is our divisor. So let's go ahead and do the little long division. We have 55, and we're going to divide it by 10. All right, if I count by tens, how close can I get to 55? Well, I would get up to 50, and that the only way, or when we count by tens to get to 50, that would be 5 times. So 10 can go into 55 5 times. 5 times 10 is 50. What do we have left over? We have 5. That's going to become our fraction as the numerator, and the 10 will become our denominator. So the answer, the mixed number, is 5 and 5/10. That tells me that this fraction, 55 hundredths, which is the same thing as 5 and 5/10, it's going to be in between the whole number 5, and it's going to be between 5 and 6. D, same thing. We've got 32 over 40. Remember, 32 is our dividend, and the denominator will be our divisor. 32 over 40. Well, guess what? 32, our numerator, is smaller than our denominator, so that means this is not bigger than 1. So technically, between the whole numbers, 3240 is going to be between 0 and 1 whole, because 40 over 40 is 1 whole, and 32 over 40 is smaller than 40 over 40. Now let's go to our division over here. We already set it up for us. If you count by 40s, how many times or how close can we get to 32 without going over? We can't. 40 is too big. So we're going to have 0 wholes. 0 times 40 is going to be 0. We're going to subtract. What do we have left over? We have 32, which ends up being our fraction, our numerator, and our 40 is going to be our denominator, which then matches this answer over here. And let's look at number 3. Number 3 says Greg spent $4 on 5 packs of sports cards. They want to know, how much did Greg spend on each pack? All right, so let's think of our tape diagram. So we're going to go ahead, and this is going to represent two things, or it can represent one of the two things. I want you to think, does this represent money, or does this represent 5 packs of sports cards? Remember, the question says, how much did Greg spend on each pack? So this tape diagram is going to be representing how much money he spends. So we know he spends $4, so we can put this $4. And so then he buys 5 sports packs. So that means we're going to take our tape diagram and divide it into 5 equal parts. So the price of each pack are going to be the same. So if we think about it, this is what we're trying to find, because the other boxes will be the same. Let's think. Let's write this out. Okay, if we have 5 units, that means 5 boxes in the tape diagram. Those 5 boxes, they're actually going to equal the number on top of the tape diagram, which is going to be 4. Now, if I want to figure out what 1 unit is, I'm actually going to take the number on top, which is $4, and it's going to then be divided into 5 boxes. And now we're going to go ahead and say 4 divided by 5 is the same thing as saying 4/5. Now the question says, how much did Greg spend on each pack? So we're talking about money, but if you think about this fraction that we hear doesn't really give us an actual money value. So I'm going to teach you a cool little trick to figure out, okay, this fraction is 4/5. Each pack is 4/5. But in money, we need to kind of do a little bit extra work, which is not that hard, but we're going to do a little extra work, and we're going to say, okay, let's take 4/5, and we're going to make it into an equivalent fraction that's more relatable to money. Now, Let's think, okay, money, let's see if we can actually get to a dollar. A dollar would be technically, think of it as 100. Okay, this 100 represents not $100, it represents a dollar. Okay, now if we need to ask ourselves, what number can we multiply by 5 to get to 100? So if you count by fives, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, so on and so on and so on. Um, if we counted by fives, we would actually be counting 20 times to get to 100. So 5 times 20 is 100. You can also think of it as, okay, 5 times 2 is 10. There's the 10 right there. So 5 times 20 means you add a 0 to get to 100. So let's think about, okay, now if we're doing 5 times 20, then what's 4 times 20? Well, let's think easy. 4 times 2 is 8. So 4 times 20 would be 80. So this is going to give you a clue. If this is technically 100 is technically $1, 80 is not going to be $80 and it's not going to be $8. It's actually going to be smaller than a dollar. So 80 is going to be 80 cents. So that means each box is going to be 80 cents. So each pack is going to be 80 cents. And if we were to add up all of these 80s cents, 80 plus 80 plus 85 times, we would get $4. So now we can write Greg spent 80 cents on each pack. Finish it off with a period for your sentence. Now let's look at part B, the continuation. It says, well, if Greg spent half as much money and bought twice as many packs of cards, how much did he spend on each pack? Explain our thinking. So, okay, half as much money, so technically half of 4 would be 2. So we can now make a tape diagram again and say, okay, now this is no longer going to be $4. We're going to say he actually spent $2 because half of 4 is 2. And then the other clue was he bought twice as many packs of cards. So if he originally bought 5, that means he now bought 10. So we can make 9 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now he has 10 packs. They're all the same amount. They're all equal since we're dividing here. So let's write this out, okay? How many units do we have? Well, we have 10 units. We have 10 boxes inside the tape diagram. So all those 10 boxes, all of these 10 boxes would equal the number on top, $2. Now, if I want to figure out what 1 unit is, that would be 10. Sorry, not 10, that would be 2. Remember the number on top of the tape diagram, it would be 2. And we're going to divide it into 10 boxes. Which then, as a fraction, you know that 2, which is our dividend, is going to be the number on top. And the divisor is 10, is going to be our denominator, so that's going to be 2/10. So he spent 2/10 on each pack. Well, 2/10 is not money. 2/10 is not money. We want to make sure that we can show how is 2/10 actually in money form. Remember the trick up there. We're going to use the dollar, which is going to be represented by 100. So 10 times what would give us 100? 10 times 10 would give you 100. So that means 2 times 10 will give you 20. So remember, this 100 is actually going to represent $1, and this 20 is not going to be $20. It's going to be smaller than a dollar, so it's going to be 20 cents. So each pack of cards now on this part B is going to be 20 cents. So here's our explanation. We showed a nice little diagram, so now let's go ahead and write our thinking down. We can say Greg spent 20 cents. Make sure you have the cent sign. 20 cents on each pack, period. All right. And that will end lesson 4. Nice job, guys. I'll see you on the next lesson.